Hi, my name is Lucas Van Assen, and I'm an electrical engineering major at Grand Valley State University, graduating in August of 2024. I was the team captain for the DornerWorks Nerf Turret project.
Hello, my name is Seth Feinenbell. I'm a computer engineering student, and I was the main FPGA design engineer and embedded Linux developer.
I'm Brendan Kaufman. I am a computer engineering student graduating in 2024. What I did on this project was I was the secretary for the team, which meant I kept notes and everything. And then I was also in charge of the software development for the application space, which meant I designed the software for the mobile application, the software that the Linux was using to interact with the mobile app.
Hi everyone, my name is Ian Lilly. I am an electrical engineer and I'm graduating Grand Valley in 2024. My role on the project was to develop the hardware and the custom expansion card that was needed to interface all of the peripherals for the project. That includes the mobile app, motor drivers, servo drivers to control the turret. Also relay video from the camera to the Wi-Fi, through Wi-Fi to the mobile app. That was my job, was to develop the custom PCB, the schematics, and to also test the board when it came in.
We are GVSU project team number 3, and we created the DornerWorks Nerf Turret demo this year.
The goals of our project were to develop a remote-controlled Nerf Turret that utilized DornerWorks intellectual property coupled with an FPGA architecture and a custom hardware board to control a small turret using a mobile app that also had a video stream from the turret and also fire Nerf darts on command.
The DornerWorks Nerf Turret project this year was intended to showcase DornerWorks' several areas of expertise. That includes rapid prototyping, SEL4 development, IoT development, FPGA development, and hardware development. We set out to achieve those 5 goals with a Nerf Turret, and the Nerf Turret would implement SEL4 as the hypervisor. In my role as team captain, I supported pretty much everybody at some stage or other with their portion of the project. And one of the parts I spent the most time on was implementing Linux on the Korea. This is the development kit that we chose to use, and it has some benefits of Pi hack header, which is a standardized interface with 40 pins, so lots of I/O, as well as being a modern platform with a lot of support and plenty of hardware for both transmitting via Wi-Fi a camera feed as well as actually using a camera. In my role as supporting the Linux development, I spent a lot of time doing device driver development, working with Seth to get our PWM and GPIO drivers working, as well as working with Brendan to get our Wi-Fi drivers working, including initial development on building the Wi-Fi driver into Linux.
On this project, I covered a bunch of different aspects of the project, the main one being the mobile application. To do that, I utilized the Flutter framework, which creates cross-platform applications. This allows the project to have a future continuation of trying to add an iOS aspect to it. We focus primarily on Android, but to do this, we had to utilize packages that already existed inside the Flutter framework. Came across some pretty big issues with getting video to work. So we had to come up with a different solution of communicating via socket level communication, and sending the image as a stream of data manually, and then copying that into an image and taking that image and displaying that to the screen.
My role on the senior project team was that of the main hardware developer. There was a hardware expansion card that needed to be developed that can help interface the Korea with all of its peripherals, because the Korea does not have all of the requirements needed for controlling a Nerf Turret. Some of these requirements included a Wi-Fi chip that was needed to stream the video controls to the mobile app. Others included motor drivers in order to drive the shooting mechanism of the turret, as well as servo drivers using PWM that would be used to control the aiming in the direction of the turret. All these things need to be added onto a expansion card, which is what I helped develop in Altium Designer, which is what we learned here at school. And so this card is only a couple inches wide, and it also has the Pi hat header that can be interfaced onto the Korea, which already had one installed. And that made it pretty easy to just develop this and make it kind of a plug and play type of system. And all that needed to be required was a little bit of an external power source, 12 volts, which you can just get because that's the power for the Korea as well. And then all the peripherals were able to work. And then the FPGA team and the embedded Linux team were able to use the hardware expansion card to interface with the peripherals and control the turret as we needed to.
For my role in the demonstration, a custom Vivado FPGA project was built for custom programmable logic in the design. So this included some custom logic blocks so that the Korea system on module could work with the development board. This included SPI, UART, PWM, GPIO. We then tied these custom IP blocks to pins that were connected to the custom daughter board that we created. This way we could utilize these different bus interfaces within the project. After the logic layer was completed, a custom operating system called Linux was used within the project.
Another big issue was connecting the Korea, the board that we're using, to Wi-Fi. I worked on that by helping build the drivers helping to build the drivers on the embedded Linux.
Some challenges on the hardware card were a reduction of scope initially. The original plan was to make a full development kit like the Korea board here, but that's turned out to be a little too much to handle for one person. So we got it reduced down to the little expansion card that we have here, which turned out to be a very, very good idea because it helped us get the project done on time, and it still met all of the requirements that we had for the project in the first place.
How was it working on the senior project team throughout the semester?
Yeah, so working on the senior project team allowed all of us to focus on our specialties. So, for example, every single one of us worked on different things at DornerWorks or at other companies for our co-ops. And we all took different classes, and we all have the same base knowledge of engineering. That allowed us all to focus on our strengths and create the best aspect we could in those strengths, while also still having this base knowledge of things that we can work on together. And that allowed us to break up the project into a bunch of different tasks and different activities for each individual.
So Seth, what would you say your favorite part of the project was?
My favorite part of the project was working with Linux, the custom Linux operating system. I learned a lot through struggling with the SPI bus on this interface. There was multiple configurations that were needed to get SPI up and working within the operating system to be able to actually manipulate signals on the daughter board.
So what were some of the major challenges that you encountered as a team?
As a team, some of the major challenges that we encountered were SEL4 was a hypervisor that we were planning on using and breaking out functionality into two different virtual machines. Unfortunately, the tools that we were intending on using for SEL4 didn't pan out quite the way that we expected, and that caused significant delays in development cycle, with a lot of time being sunk into that, and then eventually that requirement being scrapped altogether.